Today we're going to start to take a look at how to solve log equations as well as exponentials. So I'm going to remind you of a few properties that we already know that are useful when we're trying to solve these equations. So the first property is the one-to-one property, and that's if two exponentials have the same base, then their exponents are equal to each other. In log form, if two logs have the same base, then what you are taking the log of must be equal to each other. The other option for solving equations is if you can get it in the form where you can use the inverse property, where the log base A and an exponential with the same base would cancel each other out, leaving you with the power on the exponential. Or in the reverse form, if you have A to the log base A power, those will cancel each other out as well using the inverse property, and you'll be left with what you're taking the log of. So let's see how this works. Today we're going to look at some basic equations, and we will get into some more complicated equations tomorrow. Our first one, we're going to solve without a calculator. So we're going to learn how to solve log equations and exponentials using the properties of logs and exponentials that we know. So our first one, we have 4 to the x power equals 32. Now initially, looking at this, you wouldn't think you would be able to solve this without a calculator because 32 is not a perfect power of 4. However, if we can rewrite both of these with the same base, then we can solve for x. And in this case, 4 and 32 can both be rewritten as base 2. So I'm going to change my 4 into a 2 squared. And then this will be to the x power. And 32 I'm going to rewrite as 2 to the 5th power. Now our power of a power rule, we have 2 squared to the x power, so we're going to multiply those exponents together. So we get 2 to the 2x power equals 2 to the 5th power. And now that we have the two exponentials with the same base equaling each other, this is that one-to-one property, we can set those exponents equal to each other. So 2x must equal 5. And running out of room here, so I'm going to go off to the side. Therefore, when we divide both of them by 2, x equals 5 halves. Our next one, same property that we're going to use, we have 1/3 to the x power equals 9. So we're going to rewrite both of those with the same base. Hopefully you recognize both of those as base 3. 1/3 is 3 to the negative 1 power because it moved it to the denominator. So it's really important that you're comfortable with those negative exponents and know how to use them in order to solve some of these equations. And of course 9 is 3 squared. So we're going to use our power of a power rule again and multiply the negative 1 and the x. So we get 3 to the negative x power equals 3 squared. Dropping the base, now that they're the same, we have negative x equals 2. And of course, dividing both sides by negative 1, we get x equals negative 2. And I failed to heed my warning to check my answers. With exponentials, it's not as essential that you check your answers because the domain for exponentials is all real numbers. So when you solve an exponential equation, your answer is going to work. But remember, when we get to log equations, the domain of a log is x is greater than 0. We can only put positive values into our log. So when we get to those log equations, we're going to have to be sure to check our answers and make sure that we don't get any extraneous solutions or solutions that might work while we're solving but don't work in the initial equation. Last one for the exponentials, we have this time a multiplication out front. We have 5 times 9 to the x power equals 135. So of course the first thing we want to do is isolate that exponential. So we're going to divide both sides by 5. And I'm sure all of you recognize that 135 divided by 5 is 27. So you would not need to grab your calculator for that, I'm sure. Now taking a look, we've got 9 to the x power equals 27. Some of you might be thinking x equals 3 because 9 times 3 is 27, but be careful that you don't fall into that trap. This is 9 to what power? 27 is not a perfect power of 9, so we're going to rewrite both of these as base 3. 3 squared gives us 9, and 3 cubed gives us 27. So when we use our power of a power rule, we get 3 to the 2x equals 3 cubed. And for some of you, now that you've seen this a few times, you may be able to skip the step where you write it, this step right here, where you write it as the power of a power rule, and you may be able to jump to this one right here, and that's fine, as long as you're showing enough work that I can follow your thought process. Dropping those bases, we get 2x equals 3, and dividing both sides by 2, we get x equals 3 halves.